Hello guys, welcome back to TechieTech. Guys, in this video, we will see about Proteus simulating software. So Proteus is a simulating software that simulates electronic circuitry. So now the question is, why it is so important? Now for electronic project developers, it is very often a headache for him to test his electronic circuits before actually constructing it. Because if the developer constructs the circuit without testing the circuit design, then he or she may end up damaging the components if there is any fault in the circuit design. So it is always recommended to test the circuit design before actually constructing it. Now to test an electronic circuit, a number of instruments is required. For example, oscilloscope, ammeter, voltmeter, terminals, etc. But many of the instruments are so costly. So now if there is no other way to actually test your circuit, then you can always use the simulating software like Proteus. In Proteus, you can actually design your circuit and virtually analyze it how your circuit is doing. For example, if there is any fault in your circuit design, then the simulation itself will say you that there is a fault in the design. And if the simulation runs successfully, then you can actually build your circuit. Now to build your circuit, you might be looking for a PCB or printed circuit board designing software. But let me tell you that this Proteus software itself can facilitate you to design your printed circuit board with the components that you used in the schematic. So in short, Proteus software is used to simulate electronic circuitry and also to make printed circuit board designs. And let me tell you that Proteus does not only support the passive components like resistors, capacitors, transistors, LEDs, etc. but also it includes microprocessors, microcontrollers, and lot of other variety of integrated circuits. So it basically means that you can also test your code that you wrote for a microcontroller, whether it is running perfectly or not. So in this video, we will see a brief introduction of Proteus simulating software. We will see various components of the software interface and we'll build a very simple electronic circuit and simulate it in this software. So without wasting any time, let's get started. So let me first open the Proteus suite software from desktop. So presently my version is 8.13. You can always download the latest version, that is 8.16 from the official website. If you don't have the Proteus software installed on your computer, you can follow the Telegram link that I have provided in the description area. Okay, so let's start. So this is the home page of Proteus software. Here you can see there are a lot of tabs, like this is getting started. It shows some tutorials about how to use the software. Then below it there is a help button, help tab, and beneath it there is about. So it shows how much memory is free and all these details. Okay, now let's jump to the start tab. Here you can see you can open your existing projects by clicking the open project button. You can create a new project by clicking this button. You can create new flowchart, or you can open some samples that is provided with the software. So first create a new project. Okay, give a name to your project. For example, I am giving a name like sample circuit. Okay, now give it the path that is required. So I will save it here. You can change your directory accordingly and click on next. Now create a schematic. It is required for simulation, so let it be default. And if you want a PCB layout, then select this, otherwise you don't need to select this. So we won't create a PCB for this project, so let it be unchecked. Do not create PCB layout. Click next. Then this is not a firmware project. Firmware means there is a coding involved in this project. So in our case, no coding is involved, so we will let it be no firmware project. Then click next. Okay, then click finish. So it will open a new window, that is the main window where we will create our schematic. So before creating schematic, let me go through one by one all these tools that is in the left side of the window. So first, this is the selection mode. So whenever this mode is active, you can select any particular component and then you can drag and drop it from every position of this window. Now this is the component mode. So in component mode, you can select any particular component in this schematic. We will see it later. And there are other modes as well, like junction dot mode, level mode, and text mode, etc. So now let's just jump to the terminal mode. Here you can see various kind of terminals. For example, this default terminal, if it is selected, then you can create a default terminal like this. And there is input terminal as well. You can create input terminal like this. And there are a lot of other things, but most importantly, the power and ground terminal. This is the ground terminal and this is the power terminal. Now ground terminal is very important for simulation purposes, and also the best thing about terminals is you can rename it. For example, I am renaming it to say terminal, and if I give a same name to this terminal like terminal, so now Proteus will understand that these two pins are internally connected. You don't need to actually connect it. Now there are this device pins mode. You can name any particular pin of any ICs by this mode. Then there are graph mode. You can create any particular graph followed by this active pop-up mode. These all are not required presently. So now let's see the generator mode. Now in this generator mode, you can give any power source to your schematic. For example, when DC is selected, if I click DC and then click in on schematic, a DC source will be added to the schematic. Now if you double click it, you can change the properties of this DC source. For example, I am renaming it to VCC and I am changing its type to DC and give a voltage of say 5 volt. So now this will act as a power source of 5 volt DC to all these components that will be used in the schematic. Now you can also add sine power, and you can also change its properties, like you can rename it. For example, I am renaming it to AC. Then you can change the voltage value. For example, let me give it 220 voltage sine value. Click OK. Then it will act as a 220 volt sinusoidal power. A lot of other power options are available. You can use any of them in your schematic. And then there is probe option. Like if you don't want to use any voltmeter or ammeter in the schematic or in the simulation, you can just click a probe. For example, I am clicking voltage probe and I just need to see the voltage of this power source. So I will just connect it to this probe, and when you click the simulation button, it will show 5 volt. And now comes one of the most important component of Proteus simulating software, that is virtual instrument. Now there are a lot of virtual instruments available on this Proteus simulation. There is oscilloscope. If you select it and place it on your schematic, then it will look something like this. Then there are logic analyzer, counter, timer, virtual terminal, and a lot of things like DC voltmeter. You can place your DC voltmeter like this. You can connect positive and negative accordingly, and then when you simulate the inter-schematic, it will show what voltage is there. So like you can add DC ammeter, AC voltmeter, ammeter, wattmeter, etc. And we will use some of the instruments in our circuit simulation that I have created now. And there are some 2D drawing animation tools, like this is a straight line. If you select it and like a MS Paint like something, and you can draw a straight line like this. You can draw a rectangle like this. You can draw a curve like this. So like this, and you can add some text by clicking this A button here, and then you can say anything and then click OK by selecting all the properties. Click OK and it will add like this. So we will see it in details. Now let me first remove everything from the schematic. Now we have to click this selection mode so that we can select everything, and press the delete button on your keyboard and delete everything. Now click on the component mode. First we need to add some components in our schematic. So to add components in your schematic, you have to first click on the component mode if it is not selected here. Then you have to click the P button. P means pick component. Then you can search for anything you are looking for. For example, I am looking for resistor, so I will search for resistor. So I am looking for a resistor, so I will click the resistor category. And then if you are looking for exact specification, then you can search accordingly, but in this case I am looking for a generic resistor. So I will search for generic, and there I will select this, and you have to double click it, and as you can see, this component is loaded in this library. Then I am looking for a LED, so I will search for LED, and I want a animated LED. Okay, you can find something here, LED Aqua. This is an animated LED model. So when you simulate the entire schematic, it will glow or it will not glow. So you can easily understand whether your circuit is working properly or not. So I am selecting this, again double click it to select it to load it in the component list. Then I am looking for a push button. So I will search for it, and I will select this push button here. So when you simulate the circuit, you can actually press the push button or release it, and the circuit will act accordingly. So I have also selected it, and it, as you can see, this is loaded in this library. So for now, these three are the components that I want to use. So now close this wizard, and then as component mode is selected and this button is blue colored, so it is selected by default. So when you press click, so it will by default insert a button on the schematic. Then if you want to place your LED light, then you have to select this, and automatically it will place a LED light in the schematic. And then you can rotate your LED light accordingly. Just right click it and rotate clockwise or anti-clockwise or any particular angle that you are looking for. So I will rotate it in anti-clockwise 90 degree like this, and then you can just click it here and you can drag it to any place you want to. Okay, but now I want a resistor because I want to limit the current flowing through the LED. So I will put a resistor in series with the LED. Now the value of resistor is 10 kilo ohm, as you can see here. But if I put a voltage of 5 volt and the resistance value is 10 kilo ohm, then the current will be so less that the LED might not actually glow. Now I will show it in simulation. Okay, so connect these two buttons. Now as you can see, I am just clicking here and automatically a wire is being generated, and then I will click it here. So these two terminals are connected now. Likewise, I am connecting these two terminals, and now I want a positive 5 volt here in this pin and a ground pin to this pin. So what I will do, I will give a DC power source from the generator mode. So I will give a DC source and put it here and just connect the positive lead to the push button. And now I want to edit the parameters. I want to raise the voltage to 5 volt. Then click OK. And now I want to see the current flowing through the circuit. So I will place a ammeter, DC ammeter, to here. And again I will connect the positive to this pin and negative to the negative return or ground pin of the source. But now in this source there is no ground pin, so I have to give a terminal called ground. In the terminal mode, select the ground. It is very necessary to complete the circuit, otherwise no current will be flowing through the circuit. So I will just connect the ground to the ammeter. Now our circuit is ready to be simulated. So let's now simulate. So there are 4 buttons here. This play button will start the simulation, and this will pause the simulation, and this will stop the simulation, and this will just advance the simulation by 1 animation frame. If you want a detailed view of animation, you can just pause the animation and just see the step-by-step simulation by clicking this button. So now let's just simulate the entire thing. Now the circuit is running. As you can see, the current is not showing because the current is so less that the ammeter cannot actually identify it. So just you cannot edit anything when the simulation is running. If you want to edit anything, as you can see, the simulation must be paused while measuring. Okay, so I am just clicking the push button. As you can see, still no current is being shown, but that doesn't mean that no current is flowing. Maybe the ammeter is not able to show the result because it is so minimum. So just stop the simulation and go to the settings of ammeter. What I did, I just double clicked the ammeter and it has showed some properties. So as you can see in the properties, display range in the ampere range. So I will just select the milliamp range. then click OK. Now let's see what happens. Now click on the push button. As you can see, it is 0.29 milliampere flowing through the circuit, which is not sufficient enough to glow the LED. So that's why the LED is not glowing. Now what I am doing here, I am just clicking the mouse continuously. I have not released my mouse, but what you can do, you can just click here so that it will stay on, and if you click it again, it will stay off. Okay, now let's stop the simulation and decrease the resistance value. Presently resistance is 10 kilo ohm. I am just decreasing it to say 220 ohm, and you have to just enter 220, nothing else. If you enter K, it means 220 kilo ohm, so keep it 220, then click OK. Then again run the simulation, and now if you click the button, you can see the LED is glowing, and the current flowing through the circuit is 12.6 milliampere. That's why the LED is able to glow. Now let's stop the simulation. Now let me show you whether if there is any fault in the simulation, in the circuit, then how will the simulation tell you. So let me short circuit the entire circuit. For example, just connect this positive to the plus pin so that the positive is directly connected to the ground, and let's see what happens when you start the simulation. And as you can see, fatal simulation error encountered. If you can see the simulation log as well, so it will say that there is some problem in the circuit designing. You can see details here, like where is the problem. As you can see, DC ammeter, everything is mentioned here. Likewise, you can get errors if there is any problem in the circuit. So for now, let's delete everything. You can click on this selection mode and then select everything individually like this, and you can select multiple components by clicking the control button like this, and then delete accordingly, or else you can just select all the things like this and click delete. Now let's build another circuit. So again, see the component mode, and then you can pick other components as well. Now we can run the simulation, and as you can see, when we are pressing this button, the LED is glowing, and when we are releasing it, the LED is not glowing. So now let's stop the simulation, and now let's see a magic of terminals. So just remove this wire and add a terminal. So go to terminal mode and add terminal. Now you can select default terminal, but in this case we need a power terminal because we want to add a power to the push button. So select power and add a terminal here. Now what this power terminal will do, it will say Proteus, okay, there is a 5 volt in this node, in this point of this schematic of the circuit. So we don't need any additional source to be inserted in the schematic. Just delete it. And now again run the simulation. See, it is working perfectly. So you don't need any additional source when we are requiring only plus 5 volt, because this 5 volt this power terminal itself means that there is a 5 volt in this terminal. And now if you want to use the default terminal, and then let me show how you have to delete this. Just delete it and add the default terminal here. But this default terminal works with nomenclature. Like if you are renaming it, say I am naming it VCC. Now it will search the entire schematic where other VCC terminals are. Now there are no other VCC terminals, so Proteus cannot understand whether what is here. there is no power source, so it cannot simulate. So I am again adding a DC source here and just inserting properties to say 5 volt, and the naming is not necessary here, and I will connect a terminal to the source. Again choosing the default terminal, and I am connecting the terminal to the source, same name to this terminal, that is VCC. And now as you can see, the name is same. This terminal is also VCC and this one is also VCC. So now the Proteus will understand that this source is connected to this terminal as well as this terminal. So now let's simulate it. And now I am pressing the push button, and as you can see, the LED is glowing. And now let's experiment something. Just change the name to say VCC1. Now simulate it. It won't work. Again, if you change the name to VCC1, that is the same as the earlier one, then again if you simulate, as you can see, the LED is glowing. So I hope you guys have understand the terminology that the terminals use. Like this you can simulate any electronic circuits of your choice. Okay, so now we can save the entire simulation. You can just press Ctrl S to save it, and let me show you where the file is saved. Just close it, go to the directory which you selected when you created this project. So I selected my own directory here, and then you can find the sample circuit, that is this. Now if you double click it, it will open the Proteus simulation software and your circuit in your screen. Okay, so that was pretty much as an introduction to this Proteus simulating software. In the next videos, we will see many simulations of many circuits that we will build eventually, and also we will see the PCB designing suite as well whenever required. So thank you for watching this video, and stay tuned to my channel, and also do like, share and subscribe if you like my effort, and don't forget to press the bell icon to never miss an update from this channel. Thank you.